more about curves and graphs. So last time we gave a kind of explanation that relied on the zeros of a function, like if a zero is a function of 2 zeros here, then we can only have one, we have to have like one curve between them. And we can't have like something that goes through again. But that doesn't really cover the case of like, what about something like this where it doesn't go through the zeros? So we're going to talk about this a little bit more in depth today. And to do that, we're going to introduce something that comes up in more advanced math it's called the derivative, represents the slope of a function. So there's an example of finding the derivative. Say we have a parabola-shaped thing, and we want to find the derivative or the slope of it. So this is our function, and we want to find the slope of the function. We want to plot the value of the slope at every point. So here the slope is, well, we're going down into the valley, so the slope is negative. Right here we're at the bottom of the valley, so the slope is 0. If we go left or right, we're not increasing or decreasing. And at here, maybe the slope is positive because we're going up. We're going up now, so positive slope, positive rate of change. So we see that our slope is just a line. The values of our slope make a line. And so the general finding with polynomials is that if you've got a polynomial of degree x squared, say, then the slope of that polynomial is itself represented by a polynomial of 1 less degree, so in this case degree x. Just to convince you of this, let's do another example. Let's do like a 5th degree polynomial. So if we have a 5th degree polynomial, let's say it looks like 1, 2, 3, 4, 5, something like that, with five four humps in it. Then if we draw the slope of it, well, here the slope is increasing, so let's put it in the positive spot. Here the slope is 0, so not 0. Here the slope is negative. Here the slope is 0 again, 0. Here the slope is increasing. Here the slope is 0. Here the slope is decreasing. So, whoops, I missed it. 0. That was supposed to be 0. Now the slope is decreasing, so we put it in negative. Now it's 0. Now it's 0. And then it's increasing for all eternity afterwards. So our slope looks kind of like this, and that's like an x to the 4th polynomial. So yeah, you can try it with any kind of function you want. It'll come out to the same kind of result, or any kind of polynomial function rather. So let's try. One thing to note before we delete all this is that whenever the slope crosses from being negative, or from being positive to negative, that's like a peak in the graph. So this crossing from positive to negative slope represent this peak in the graph. Likewise, a crossing from negative to positive, like right here, that represents a valley in the graph. Another peak, another valley. So whenever the slope crosses over 0, that represents a turning point in the graph. So this says 4 zeros here, 4 crossover zeros. So this has 4 turning points. So let's go and construct. Let's construct our functions again. So x to the 0, that's like a constant. So that's like equals to 1. That looks like just something like this. Just a flat horizontal line. Now, if we want to draw an x to the first polynomial, then we can look to this polynomial and be like, well, we know the slope of this polynomial has to be given by this polynomial. So how should we draw it? Well, the slope, this polynomial always has a value of 1. So the slope of this polynomial has to be constant at all points. So that represents a line with constant slope. Now, if we want to draw an x squared polynomial, well, we can look to the x to the first polynomial to see what the slope should be at each point. So here we've got negative slope. So we should be going down at this point. So going down here. At this point, that's where our slope is 0. So it starts, instead of going down, it starts to go up here. So the slope is totally flat here. So maybe we have something that's totally flat. And then here the slope is, we're going up, because positive value in here. Now if we connect this, then we get our parabola. Now if we continue this, do an x to the third function, well, we're starting out the slope, since x squared is positive here, the slope of the x to the third function should be positive. So let's say we're going up here. And now here is a crossover point. It stops being positive, starts to go back negative. So the slope is horizontal there. So maybe it looks like this. And then the slope starts to be negative here, negative. Then here it crosses over again, and instead of being negative, it starts to become positive. But at this point, the slope is 0. And then after that, it becomes positive. So that's in x to the third, like, polynomial graph. Now, if we continue to do this for x to the fourth, then we'll get something like, well, initially it's positive, and initially the slope, initially it's negative. Yeah, initially it's negative, and then at the end it's positive, and then there's like some loop-de-loops in there. So we'll get something like this, and like x to the fifth. So you can kind of see where the turns are coming from. The turns are just coming from the slope function having a 0. 3 turns here. Each one of them corresponds to a hump here, or a turnaround point there. There's 1 0 there. That corresponds to this turnaround point there. So that's another way to look at it. Again, this is using some math that comes in later. So if this doesn't make that much sense, don't worry about it yet. There will be more on it in the future. But if you can see what's going on, this is a kind of handy way to kind of remember it.